This is going to be Chapter 10, Conic Sections in Analytic Geometry. So here's where we start looking at things that are not really quite functions. So actually the only one that we're going to talk about that's actually a function is the parabola, which is what we're going to kind of talk about today. So we're going to talk about the parabola. And basically what you kind of want to know about conics is that there's basically three different types of conics that we're going to talk about in this class. So parabola is the first one, ellipse is the second one, and then hyperbola is the third one. So these are going to be really important, especially the parabola for Calc 1. So we've talked about parabolas extensively. So we know that a parabola can be like a happy parabola or a sad parabola based on the value of a. So you usually have it in this form, if you remember. So, and we know that this is a function, but we're going to express parabolas that maybe are not in this form and they're kind of going sideways. So we're going to start off by something called the geometric definition of a parabola. So let me give you the geometric definition. So basically what the geometric definition says, so how do we define a parabola geometrically? So basically a parabola is the set of all points in the plane that are equidistant from a fixed point, and this fixed point is what we call F, and this F is called the focus, and a fixed line. Okay, and this fixed line is what we call the directrix. Okay, so here's the geometric definition. So you have a parabola, it's just a set of all points in the plane that are equidistant from a fixed point F, which is called the focus, and a fixed line called the directrix. Okay, so if we were to look at what the parabola basically is doing, because we've never talked about focus and directrix before. So this might actually be the first time that you've ever heard these words before. So you have a parabola, and basically you have a point, and this point is what we call the focus, and the focus is not a point on the parabola. So this point is and we're going to call it 0, p is what we call the focus. Okay, so basically from the origin, if this is centered at the origin, this is p units. Okay, so basically what this is saying is that if I were to choose a point on the parabola, the distance from here to the focus, d1, is going to be equal to the distance from a line called the directrix, which is also not graphed. So from this line, let me make it a little bit better. So let's say the line is up here, such that this is p units. So the line is right there, and the distance from here to here, which is d2, is going to be the same as d1. Okay, so that's basically what that's saying. So these two distances are the same. So that's basically what the geometric definition of the parabola is. Okay, so this line is what we call the directrix. So you can clearly see that the equation of the directrix is going to be y equals negative p, because if this is p units, and going down is going to be negative p units, or going down p units. Okay, so I can, if you want to know the derivation of it, basically you want to find the distance. So the distance one, you can actually do it by saying this is a point xy. So find the distance between xy and 0p. And then d2, you can literally see that from here to here is just going to be y units, because that's how many units you go from the origin up. And then from here to here is just a distance p. So the distance 2 would be the absolute value of y plus p. So find the distance of this, equal it to this, and you will end up getting the equation of a parabola, which actually is this. So you end up getting x squared equals 4py. So if you're interested in the proof, just let me know and I can give you the proof. But this is what you end up getting. So this is a very different type of equation that we've had for parabolas. Usually we would always see it in this form. But in this case, this p has the focus. So it tells, you can actually figure out where exactly this focus is going to be. Sometimes you can see it as 1 over 4p x squared equals y. So here's another way that you can kind of think about it. So like if you want to have it just with y equals something, this is just so you can use this one or that one. Now, a couple things about this particular formula is that the vertex here is going to be 0, 0. So that's not always going to be true because you can always move a parabola. And we will do that after we're done when we do all the conics, then we'll go back to the parabola and we'll do when everything is shifted. So here the equation of the directrix is going to be y equals negative p, no surprise there. And then the equation or the point for the focus is going to be 0, comma p. Okay, so that's basically what we have. Now notice that depending on what the value of p is will determine if I have a happy or a sad parabola. So if p is positive, you can see that you're going to have an upward parabola. And then if p is negative, you're going to have a downward parabola. So in this case, the value of p will depend. Now, one of the things to kind of really know is that when we're talking about the focus is always going to be in the inside of the parabola. So keep that in mind. Whenever we're looking for the focus will be in the inside. Now, the distance from the vertex all the way downward, so if this was p units up and I go p units down, so the same amount of units, this line is what's going to be the directrix. Okay, so always keep that in mind because sometimes people tend to like switch it around. So keep that in mind. The focus is always going to be in the inside. Okay, so let's do a couple of examples. So we want to find an equation of the parabola with vertex 0, 0 and focus 0, 5. Okay, so this is what we want to find. Find the equation of the parabola that has this vertex 0, 0 and the focus 0, 5. So we know that the vertex is going to be right at the origin. Whoops. So here's x and here's y. We know that this is going to be right at the origin. But it doesn't tell you if it's going to be going up or down. But the focus says that you have 0, 5. And remember, like I said before, the focus is always going to be inside the parabola, which basically means that the parabola should be upward. So that means that when we write our equation, x squared is equal to 4py, in this case, we just got to figure out what p is. In this case, p is going to be equal to 5. Okay, so you're going to have x squared is equal to 4 times 5y, so x squared is equal to 20y. So this is going to be the equation of the parabola. You don't need to solve for y. You can write it as y equals 1 over 20 x squared. This is also fine, but the top one is also fine. Let's do this now. Other problem. So find the focus and directrix of the parabola y equals negative 2x squared and sketch. Well, we kind of already know what this parabola kind of looks like because there's no way that we know what p is. It doesn't really give you any indication, but we know that the graph of this parabola is going to be at the vertex 0, 0 at the origin. You know that it's a sad parabola and it's going this way. So you can plot a couple points if you want to. But still, we don't know what p is. So what we're going to do is we're going to write down the equation that has p, which in this case is going to be x squared equals 4py. Now in this case, we don't have that. We have y is equal to negative 2x squared. Okay, so what we're going to end up doing instead is going to be a really neat trick. So let me flip this around. Let me write it as negative 2x squared equals y. What we're going to do is we're going to divide this by the other guy. So I'm going to take this and I'm just going to divide it. So divide by negative 2x squared is equal to y. So what you'll see is that the y's cancel out, the x squareds cancel out, and I'm left with negative 1/2 is equal to 4p. So if I want to figure out what p is, divide by 4, So then you'll see that P is equal to negative 1/8. So this is going to be the equation, the value of P. Now we need to figure out what the focus is going to be. Now be very careful. So the focus is going to be now in the inside of this parabola. Okay, so this is going to be negative 1/8 units. So that means that the focus, the coordinate for the focus is going to be 0, comma, negative 1/8. That's going to be that guy. And the directrix now, so if you look at the directrix, now in this case, it's going to be right on top of it. And notice that I'm going to go 1/8 units over here, which means that y equals 1/8, positive 1/8, is going to be the equation of the directrix. Okay, so that's how you do something like that. So it's a really quick and easy trick that you can try to do. Okay, all right. So now let's talk about one more thing. So something else that this parabola has is something called the focal diameter. So let's talk about that really quickly. So focal diameter. Okay. So basically, if I were to kind of have this parabola that looks like this at the origin, and you have this directrix right over here. Okay, so you have the directrix, y equals p. Well, here is the value of the point 0p. So the point 0p is right there. This guy right here is what we call the focal diameter. So the length of the focal diameter. So this actually, it has a name. So this thing is called the lattice rectum. And the length of the lattice rectum, which is what we call the focal diameter, is the absolute value of 4p. Now you might be wondering, why is it absolute value of 4p? Well, we know that the distance from here to here, okay, is going to be equal to the distance from here to here. Okay, so notice that if this is p, then that means if this is directly here, that means that from here to here it should be p, and from here to here it should also be p. Okay, so because it's just symmetrical, from here to here is just basically the distance from here to the focus. And then from here to here is just a directrix. So if you wanted to find the other guy, then this must also be p. So p plus p plus p plus p gives me 4p. Okay, so that's basically what that is. So let me do an example. So what is the focus, directrix, and focal diameter of y equals 1/4 x squared? Okay, so the first thing that we're going to do is let's write it in a way that I can find the focus. X squared equals 4py. So right now, you can leave it as is, or so you can write it as 1/4 x squared equals y. If you don't like working with the fractions, you can always move it over. X squared equals 4y. And now you can just go ahead and divide it. So divide by x squared equals 4y. So the x squareds cancel out, the 4's cancel out, the y's cancel out, so you're left with p is equal to 1. So this graph that's a happy parabola is going to have its focus at 0, comma p, which is 1. So the focus here is going to be 0, comma 1. The directrix is just going to be 1 unit down, so it's going to be at -1, so y equals -1 is a directrix. And then the focal diameter is just going to be the absolute value of 4p. So 4 times 1, which is going to give me 4. Okay, so that's going to be the focal diameter. So notice that you might be wondering, why is it absolute value? Well, remember that p can be negative. So if p was negative, then there's no way that you can have a negative distance or a negative diameter. Okay, so now let's talk about parabolas with horizontal axes. So parabolas that have horizontal axes, so parabolas with horizontal axis. So those actually look like this. Y squared equals 4px. So now in this case, the y is the thing that's squared. So now you can think of the parabolas going the other direction. So now the parabola that's positive is going to open up in the positive x-axis. So here the focus will be at p comma 0. And the directrix is now going to be at x equals negative p. This is when p is greater than 0, so it opens up to the right. If you have a parabola that's opening up to the left, so there's this vertex, the focus is right there, that's going to be at negative, or let's just write p comma 0. So here's p, x equals negative p. Now the reason why I'm writing the other one positive and the other negative is because p here is negative. Okay, so it's opening up to the left. Okay. So here, the vertex, notice that they're not shifted. It's just going to be at 0, 0. The focus is going to be at p comma 0. And then the directrix is going to be at x equals negative p. Obviously, if it was p was negative, then it would change it to a positive. Okay, so let's just do one quick example. There's really not a lot to these types of problems. Just remember that these problems, if you see the y being squared, if p is positive, then it's going to open up to the positive x-axis. If p is negative, it's going to open up in the negative x-axis. So let's just do this problem. So find the focus, directrix, and focal diameter of the parabola. So x minus 1/5 y squared equals 0. Okay, so the first thing to kind of do is make sure that this is in the correct form. So let me add the 1/5 over. So you're going to get x is equal to 1/5 y squared. Usually the y squared is the thing that's by itself. So I move the 5 over so you get 5x. So here is basically the equation. So you can kind of see that when you have it in this form, it's all positive, which means that this guy is opening up to the right. Okay. So now what is this going to be? So now let's equate this to the equation of a parabola with horizontal axis, which is y squared equals 4px. So now what you're going to do is you're going to take y squared equals 4px, which is the original equation. I'm going to divide this by this equation, which is y squared equals 5x. So you can see now that the y's are going to go away, the x's go away, and you're left with 1 is equal to 4/5 p. So when I solve for this, you're going to get p is equal to 5/4. So this is going to be the value of p. So that tells me that the focus is going to be 5/4 comma 0, because remember that you can either look at the equation where you can just literally plug it in, or you can just look at the axis and be like the focus has to be in the inside, so you're going 5/4 units over and nothing in the y direction. The directrix in this case is going to be equal to x equals the negative 5/4 because it's on the other side, and the focal diameter, this guy is going to be the absolute value of 4p, which is 5/4, and this is going to give me just 5. Okay, so these problems are pretty basic. There's not a lot to do with them other than just plug and chug. We'll do shifted conics later when it's not at the vertex, but we're going to go over the rest of the conic sections.